Okay, so hello everyone. So welcome back to another lecture. So in this lecture, we'll be discussing about igneous rocks. So this lecture series will be totally dedicated to the igneous rocks. So we'll be speaking about how the igneous rocks are formed. We'll be discussing about that. What role does magma has, the different processes involved in the formation of igneous rocks, then the various textures, the structures of igneous rocks, and some of the classifications also we'll be discussing in this. But today's lecture, we'll be discussing about the following points as mentioned below. That is what is magma. Then we'll be seeing what is lava. Then the composition of magma and the types of magma. Okay, so this will be the points for discussion for today's lecture. So let us begin with this. Okay, so we'll be seeing what is magma first of all. Okay, so we'll be seeing what is magma. Okay, so magma I can define it as a molten, okay, molten rock material. Okay, this is a molten rock material which is present beneath the earth's surface. Okay, so magma is nothing but it can be defined as a molten rock material which is present beneath the earth's surface. So suppose if this is the surface of the earth, so the magma will be present here. Okay, so the magma will be present beneath the earth's surface. So it will be present beneath the earth's surface here, and which is molten in composition, or it is in liquid state. So this is known as the magma chamber. Okay, it is known as the magma chamber. So when the same magma from this magma chamber, when it comes to the earth's surface, so we call that same molten material of rock as lava. Okay, we call it as the lava. When the same molten mantle material is present beneath the earth's surface, we call it as the magma, and the same molten rock material, when it comes to the earth's surface, we call it as the lava. Okay, and the rocks formed from this magma or the lava, when it cools and consolidates, we call them as the igneous rocks. Okay, so for this, we can write down the definition for what is the lava. So we'll be defining what is lava. Okay, so it is nothing but the molten rock material which erupts, which erupts to the earth's surface. Okay, so that time when the molten mantle material comes to the earth's surface, we call it as the lava. And when the same molten mantle material, or we can call it as the same molten rock material as well, we call it as the magma. Okay, so another way how we can define this magma is nothing but molten mantle material. Okay, so this is another definition for magma, that is we can call it as the molten mantle material. If not, you can call it as the molten rock material as well. But when the same molten mantle material comes to the earth's surface, we call it as the lava. Okay, so this was all about the definition or the meaning of lava and the magma. So the next thing what we'll be seeing is the composition of magma. Okay, we'll be seeing what is the composition of magma. Composition of magma. Okay, so in this composition of the magma or lava, so it consists of the following things. First of all, it consists of the dissolved, as everything is in a liquid state, that is in molten condition in mantle. It consists of dissolved silicate minerals. Okay, it consists of dissolved silicate minerals. Next, again, what it consists of? It consists of dissolved gases. It consists of dissolved gases. Okay, so those gases can be like your sulfur dioxide, carbon dioxide, and carbon monoxide, and hydrogen sulfide as well, H2S. And these are nothing but the dissolved gases which are present in the magma as well, which is an important part of the composition of magma. So apart from that, again, what it consists of? It consists of water vapor. If there is some water present, definitely it will get converted to vapor state due to its high temperature of magma. And last thing it consists is they are rich in oxides of major elements. They are rich in oxides of major elements. Major elements. So which are those major elements? Like your silicon dioxide, alumina Al2O3, then you are in the iron oxide, manganese oxide, then you are in the calcium oxide, then you are in the oxide of sodium, oxide of potassium, okay, so etc. This all are nothing but the oxides of major elements. Okay, I will make it oxides of major elements here. Okay, so this is nothing but the composition of the magma. So we'll discuss it one more time. So magma, it consists of dissolved silicate minerals. It consists of dissolved gases. Which are those gases? Like your sulfur dioxide, carbon monoxide, okay, and hydrogen sulfide. Apart from that, it also consists of water vapor and oxides of major elements. Okay, it also consists oxides of major elements. So these things, this dissolved gases and water vapor, I can call them as volatiles also. Okay, I can call it as the volatiles. So volatile is nothing but it means impurities. Okay, it means impurities. Okay, so it consists of uh, dissolved gases like what we have mentioned here, then water vapor. This I can call it as them as the volatiles also. So apart from that, it also consists of major oxides of elements like silica, then aluminum, iron, magnesium, calcium, sodium, and potassium. So in short, this is nothing but the composition of the magma. Okay, so what the magma it consists of? So these are the uh, things which are present in the magma. So next we'll be seeing what is the type of magma. Okay, how many types of magma are there? So types of magma, into how many types the magma has been divided. Okay, so the magma has been divided into two types. First one is acidic magma. Okay, so the first type of magma, what is known as, it is acidic magma. Another name for this acidic magma is the felsic felsic magma. So why it has been given this name felsic? Okay, why it has been given this name felsic? So here you can see it is a combination of two mineral groups. So one is feldspar, all the minerals which belong to feldspar group. Okay, and next it also consists of this Si, means Si stands for quartz, quartz group of minerals. Okay, or it can be silicates as well. So as these two minerals, that is your feldspar and quartz, are in major quantity, so that is the reason why this acidic magma is also known as a felsic magma. Okay, so this word comes from the feldspar group of minerals and quartz group of minerals. Okay, so when we can call a particular magma as acidic magma or a felsic magma, so definitely there should be some criteria. So first one is silica content. First one is silica content. So if a magma is having silica concentration that is more than 65%, more than 65%, if the silica is present in a particular magma or lava, we call that particular magma or lava to be of acidic or felsic type. This was the first thing. If the silica is present in the magma in this high concentration, so definitely the high concentration of silica in that particular magma results in high viscosity of the magma as well. High viscosity, so the magma will be high viscosity. Okay, so why, you should understand why does the magma has high viscosity. So it is because it is having silica in higher proportions. So this is the case which is seen in acidic magma or felsic magma as well. Okay, so acidic magma and felsic magma will always be having high viscosity because of higher percentage of silica present in it. So next, what will be the temperature of this magma or lava? Okay, what will be the temperature? So the temperature of the magma or lava will range in some thing about 650 degrees Celsius to 806. I can write it at 800 degrees Celsius. Okay, so this magma, that is acidic magma or lava, will be having temperature range between 650 to 800 degrees Celsius. Okay, so next, again, what should be the property of this particular uh, magma? So the rocks, what will be the color of rocks formed from this magma or lava? Color of rocks, color of rocks formed. So if the rock, that is igneous rock, is forming from the acidic magma or a felsic magma, so it will be having a light colored, that in geological terms we call it as the leucocratic rocks. Leucocratic rocks. So what is a leucocratic rock? Leucocratic rocks are nothing but light colored rocks. Light colored rocks. Okay, light colored rocks we call it as the leucocratic. Okay, so you should keep in mind Based on color, we divide igneous rocks into various kinds. So light colored igneous rocks are known as leucocritic rocks. So again, what will be the speciality of the acidic magma? So we have seen the temperature as well. We have seen the color of the rocks which are forming. So next we'll be seeing uh, minerals. Okay, so the primary minerals. The primary minerals present in this particular acidic magma or acidic lava or felsic magma also we call, it is nothing but these minerals only will be the primary minerals, that is your quartz and feldspar, because majority of it is consisting of these minerals, and that is why they have given this name as felsic. So it consists of primary minerals, it consists of quartz, feldspar group of minerals, muscovite. Okay, so this will be the primary minerals which will be in more quantity. So as these minerals are in more quantity, the rock exhibits a light color which we call it as the leucocritic igneous rock. So apart from that, what is another different properties of this acidic magma? Okay, so again it will be uh, as we have discussed that this particular magma, it consists of the dissolved gases. So these gases are even present in this particular acidic magma. So here, due to the higher percentage of silica present, the viscosity goes on increasing. So you can see acidic magma is having high viscosity. Why it is having high viscosity? Ultimately it has a relation because of high silica concentration. So as there is a high silica concentration and the magma has become very much viscous, that is thick, so the gases present in this particular magma cannot escape out easily, cannot escape out easily. Okay, so while escaping, they make a violent explosive sound. Okay, so while escaping out, these gases make violent explosive sound. Okay, so this is another property of the characteristic property of this acidic magma or felsic magma. So whenever a rock is forming out of this acidic magma or felsic magma, so we are having a crust. So it will be forming a particular part of the crust. So always the continental crust, the continental crust forms from the acidic magma or a felsic magma. Okay, so you should keep in mind our continental crust is formed from acidic magma or felsic magma. So last one we will be writing the examples of the rock which is formed from this. So the rock like your granite is an example of rock which is formed from acidic magma or felsic magma. Granite, then you are having the rhyolite. Okay, so these are few of the examples of rocks which are formed from the acidic magma or felsic magma. So we'll discuss it one more time. So the magma are divided into two types. One is the acidic magma and the one more is the basic magma. So we'll be seeing the acidic magma once again. Okay, so it has been called by another name, that is felsic. It has been given this name because it consists of two group of minerals, that is feldspar group and quartz group. Okay, so this acidic magma will always have the silica concentration more than 65%, and due to high percentage of silica it is having high viscosity, and its temperature ranges between 650 to 800 degrees Celsius. And as it is consisting of this group of minerals, that is feldspar and quartz, its color becomes leucocritic, or light colored rocks are formed when this magma or lava gets cooled down. So what are the primary minerals present in this particular magma or lava? So it is quartz group of minerals, feldspar group of minerals, and muscovite. And as we have discussed that this particular minerals, this particular magma, it consists of trapped gases. So due to high viscosity, the trapped gases in the lava or the magma, which is of acidic type, cannot escape out easily. So due to that, the gas builds up inside the pressure, and due to it, it makes a violent explosive sound. And our crust has been divided into two types. So one is the continental crust and one is the oceanic crust. So our continental crust is always formed from the acidic magma or felsic magma itself. Okay, an example of the rocks which are formed from acidic magma or felsic magma is nothing but granite and rhyolite. Okay, so next we'll be seeing about basic next magma type, that is basic magma. That is basic magma. Okay, this basic magma is called by another name, that is known as mafic. It is known as mafic magma, or it is also known as mafic lava as well. So why it has been called as mafic? We'll see that first of all. As felsic we have seen, we'll discuss out this as well. Mafic, Ma is representing magnesium elements, the minerals which are rich in magnesium elements, and Fi, it is representing, that is iron element in abundance. The minerals which are having iron in more quantity are present in this particular rock, and the minerals which are having magnesium in more quantity are also present in this rock. And as these two things are present in much abundance, the magma is known as your mafic. That is another name for this basic magma itself. Okay, so we'll be seeing like your acidic magma, we'll be seeing what will be the other properties that are present in this. So first of all, we'll see silica composition. Okay, we'll be seeing silica composition, what is present in this particular magma. So in basic magma or mafic magma, silica concentration will be less than 52%. Okay, so we have to keep in mind silica composition will be always less than 52% in this particular basic magma or basic lava, or mafic magma or mafic lava as well. Okay, so next thing is viscosity. Okay, next thing we have to see what is the viscosity. So as the concentration of the silica has reduced, so definitely it will have low viscosity. Okay, so this basic magma will be having low viscosity. So I told you viscosity has a lot to do with silica concentration. If silica concentration is more, like what we have seen in acidic magma, viscosity will be high. Like if silica concentration is less, that what we are seeing in this case, your viscosity will be low. So basic magma will always have low viscosity. So after that, next point what we'll be seeing is the temperature. So the temperature of the basic magma, it will be somewhat approximately between 1000 degrees Celsius to 1200 degree Celsius. Okay, so this is the temperature of this basic magma. So after that, next property, color of the rocks formed when this basic magma cools. Okay, so we'll be seeing that color of the rocks formed. Okay, color of the rocks formed. What will be the color of the rocks? So as this is having more of minerals which are rich in magnesium and the minerals which are rich in iron, so definitely it will be having some dark color. So the igneous rocks which are having dark color and rich in these elements and minerals, so those rocks are said to be melanocritic. Okay, so melanocritic rocks are nothing but your dark colored igneous rocks which are rich in your amphibole group of minerals, pyroxene group of minerals, biotite, then you are having the olivine as well. Okay, so the rocks which are formed when this basic magma gets cooled down, it is known to have a color that is melanocritic color. Okay, so after that we'll be seeing the minerals, primary minerals which are present in this or which may be present. Okay, primary minerals. Okay, so you'll be having the primary minerals such as group wise we will be speaking. That is your pyroxene group of mineral will be primary. Pyroxene group of minerals will be there. Then amphibole group of minerals. Amphibole group of minerals will be there. Then you are having might have olivine in small quantity as well, and also you'll be having biotite. Okay, so this will be the primary minerals which will be present in this particular rocks which are formed by the cooling of basic magma or basic lava. This basic magma is also known as your mafic magma as well. So apart from that, what can we see later? Okay, so what will be the reaction of the gases? Okay, so here as we have seen, the magma consists of gases, dissolved gases present in this. So the trapped gases, the trapped gases can easily escape out. Okay, without making any explosive sound, these trapped gases in the magma can easily escape out. Why is it happening? Because it is having less concentration of silica in this, that is less than uh, that is less than 52%. And because of this less concentration of silica, what has happened? It has resulted in low viscosity. It has resulted in low viscosity, and this low viscosity allows the gases to easily escape. So this is all the relationship they are having in this. Okay, so that is the reason why this gases easily escape out. This was not the condition in the acidic magma because there the silica concentration was more. Okay, so after that we'll be seeing another properties of this basic magma. So which part of crust is formed from this magma when it cools down? So it is your oceanic. It is your oceanic crust. Okay, it is your oceanic crust which forms when your basic magma or mafic magma it cools down. Okay, or you can call it as basic lava as well and mafic lava as well. Okay, so after that, what are the examples? What are the examples of the rocks when this basic magma or basic lava when it cools down? Okay, so examples are basalt and gabbro. Okay, so these two are the examples of the rocks, igneous rocks, which are formed from the basic magma or mafic magma or lava as well. Okay, So this was a short lecture on the igneous rocks that is taken into consideration. We discussed about magma, what is magma. Then we have discussed about what is lava. Then composition, what the magma is composed of. Then after that, types of magma. We have seen acidic magma and basic magma. Okay, so I hope you have understood about this. So definitely in the upcoming lectures as well, we will be seeing the remaining parts of the uh, igneous petrology as well. Okay, so with this, I will stop this lecture here. So thank you.